Welcome, everyone. Welcome to the Observe Hands-On Workshop. My name is Lucas. I am one of the sales engineers here on the Observe team. Today, I'll be guiding you through sort of a troubleshooting workflow slash sort of Observe 101 on how to use the platform. I'm joined by Kyle Champlin, one of our product managers here as well, and he'll be facilitating some of the content through the chat. So if you have any questions as we go through this, feel free to throw them in the chat. Kyle will be there to help us out, send some links, documentation, and so on. So let's get started. Cool. Now, before we actually hop into it, a little inspirational quote from our host, Grant Swanson here. The secret of success is to do the common thing uncommonly well by John D. Rockefeller, right? So here at Observe, we do have this philosophy that everyone's trying to do observability, and some people are doing it all right. Some people are trying their best. But we do think that we found sort of a really magic formula here in terms of how we're tackling the problems in this industry today. So as we go through this workshop, keep this phrase in mind just to get us pumped up for the session that's coming up. One cool thing that we'll provide you after you complete this workshop is a little certificate signed by our CEO, Jeremy Burton. Quick little fun fact about Jeremy is that he's on the board for the McLaren Formula One team. So if you're a big F1 fan, you can go around showing your coworkers his signature, whatever floats your boat there. But yeah, in terms of the agenda, quick breakdown here. The first 10 minutes, I'm going to have you guys create a trial account within Observe so we can navigate through this process together. So if you can, Kyle, if you could throw this link in the chat for people to click on it, go to https account.observeinc.com so you can create your account as I go through the rest of the agenda, as I go through the rest of this little presentation here. We're going to do a quick overview on the actual workshop. We're going to talk about the architecture behind Observe and some of the benefits that come along with it and how we're differentiated in the market from other observability solutions. I'm going to introduce you guys to some terminology behind Observe, namely data streams, data sets, OPAL. You guys are going to be hearing these words a lot. They really tie in everything together of what we're doing here in our architecture. And then we're going to go through an overview of the actual environment, right? The hands-on environment, which is really your free trial. All the data that we're seeing here is going to be based off of the OpenTelemetry Astronomy Shop application, right? So we're getting a lot of good metrics from there. And we're going to do a troubleshooting process on top of that, right? Now, for the remainder of the time, we're going to be doing the hands-on exercise. So the actual exercise is going to be us troubleshooting a containerized service. I'm going to have some nice quiz questions for you guys as we go along to make sure that we're really putting the knowledge that we're gaining into use. We're going to do some data shaping 101 towards the end, which is going to be a bit of a challenge where we're going to use OPAL, right, our processing language, to go ahead and transform some data in some meaningful ways that we can use later on. And then towards the end, we'll have plenty of time for Q&A. Anything you guys have any questions, anything that's not quite clear, anything you want to learn more about, we'll be here for you to answer those questions. So with that in mind, let's talk about architecture, right? And I have just a quick sort of, I think it's important to use this diagram here just to illustrate how Observe is different than other solutions in the market, right? And the way I like to describe Observe, everyone, is that we were the first observability solution that was built upon a data lake, right? The data lake in this case being Snowflake. And we like to split sort of the understanding of this into two parts, data ingest part and the data transformation part. So if you follow with me here on the left-hand side of my screen, notice that Observe ingests telemetry from all of your major cloud providers, all of your major tools, whether it be host-based, containerized, Kubernetes, AWS, GCP, Azure. One of the things that we pride ourselves in is that we rely pretty heavily on open source technologies, right? Our team saw where the industry was going in terms of ingest, and we realized that open source and the avoidance of vendor lock-in is really the future of observability. So we use things like Prometheus, Grafana, OpenTelemetry to facilitate that. Because of our data lake architecture and because of the separation of storage from compute, we're able to provide you 13 months retention on all of your data by default. And all of your data really that comes into the data lake, there's no strict ingest schemas on that, right? So if you guys want to send us structured, unstructured, JSON, plain text, there's really no sort of convention as to how you want to send the data to us because all of the transformation is done post ingest. And the last thing I'll mention here in terms of the data that's coming in, we're not necessarily married to just observability data as well, right? As a matter of fact, here at Observe, we believe that observability is more of a data problem than just a telemetry problem. So we expect you to be sending us things like a CRM information, right? Your ticketing information. You want to send us sort of Jira, Zendesk information, you can. Business contextual data, right? That we can then correlate to your telemetry and give you a full visibility into your actual application. So now that we've talked about data ingest, then we do a data transformation, right? And we'll see a lot of this throughout the following slides here. But just as a quick high level, this is what we call our data graph, right? Our data graph is split into what we call data sets, and those all originate from what we call data streams. We're going to go into more detail on this, but I just want you guys to keep in mind that your data comes into what we call like amount of machine data. So let's say amount of Kubernetes data, amount of AWS data, and then we shape that data into the meaningful views that are useful for your team. So for example, in the case of Kubernetes, we take all of your Kubernetes data, and then we shape it into a container data set, a pod data set, right? A logs data set for all of the information that's coming from Kubernetes that's more meaningful to you. And we do this automatically. But let's dive a little bit deeper into that terminology, right? That I've been mentioning here. So let's start off with data streams, right? Which is really the beginning point of where your data is coming from. So as you're seeing here on the slide, Observe collects all data, system and application logs, metrics, and traces into observations, which are associated to specific data streams. You can imagine it's a source of data. Data streams are a flexible way to manage data ingestion, and each data stream sends raw observations to a source data set, right? Meaning that for each source of data that you have, we're going to have a raw data set that has all your data in it, as we'll see here in just a second. But then we've been talking about data sets, right? And data sets are derived from data streams, and they're structured with times or time intervals, as well as relations linking to or from other data sets, right? So as we can see here on the right-hand side of my screen, we can see that all of the data sets are interconnected because they're derived from one another, going all the way back to that data stream or that raw data set that we were talking about. Now, a data set has a schema, which is a set of named columns and definitions of data types and stored in those columns, right? So as we take a look into data sets, you'll see that they look very familiar to what a SQL table would look like, right? And so it should be something that you're used to seeing, but we offer a lot of flexibility on top of that. The last thing I'll mention here is that notice that there's two different colors for these data sets. Purple data sets is what we call an event data set, right? And those events have timestamps or time intervals attached to them, as I just discussed. On the other hand, blue data sets, they're tracking the state of an object through time, right? And that object could be anything from a pod to a user, to a customer, to a node, to a daemon set, right? Things that are constant through time whose state can change. The last thing I'll talk about is Opal, right? I've been sort of alluding to Opal, which is our observed processing and analysis language. Now, Opal is a query language for searching and transforming data within Observe. It is a streaming language that allows you to both shape and query your data using the same underlying functions and verbs. It is purpose-built to handle high-volume time series data and works across logs, metrics, traces, and anything else you send us, whether that be telemetry or business contextual data, as I talked about before. Now, one thing I'll mention here is that you might be thinking, oh, Lucas, another query language. The beauty behind Opal is that everything that you do in the UI, as you'll see, is transformed into Opal in the backend, right? So if you want to be a regular user of Observe who doesn't really dabble in Opal all that much, you can. While at the same time, if you want to have someone be a power user of Observe, then they can really get deep into Opal and learn all of the sort of features that sit behind it, right? So I'll just leave that with you guys. What you'll see as we go along, everything we do in the UI is transformed into Opal in the backend. So on the environment itself, right? If you guys haven't yet created your free trials, please go ahead to that link that Kyle put in the chat. Feel free to create the trial so you can follow along with us. And once again, everything's based off of the OpenTelemetry demo. One thing that I'll say is that all of the data that we'll be dealing with is going to be namespace to demo data, just to make it easier to follow and locating things. That being said, if you guys want to explore the platform and go off the beaten path, right, feel free to do it. We're not tied to just the data that we're looking at here. We want you to explore and learn as much as you can. Now, if you want to interact, right, Kyle sent the link to the application there, so you guys can go to the URL and interact with the website itself. Once again, all of the data is based off of the OpenTelemetry data, and we'll be collecting logs, metrics, and traces from it via our Kubernetes and OTel integrations, right? Just to double click on it once again, everything will be namespace to demo data, but feel free to go off the beaten path if you want. On the workshop itself, just get a little bit deeper on the agenda, is we're going to be walking through how to get familiar with the explorers within Observe, which is what we call our unopinionated views. We're going to be using logs, metrics, and traces to triage a user-reported issue in this case. And then from there, we're going to build a dashboard, sort of keep our investigation in one place and put all the context that we learned there into it, right? We're going to be creating a model as well based on raw memory metrics so that we can sort of pinpoint this issue a little bit better later on. And then we're going to quickly build a new data set at the end to enrich our logs. And that's where we're going to learn about worksheets and once again, add that back to our dashboard. Awesome. So with all of that information, all those housekeeping items out of the way, let's jump into it. Just let me move my Zoom window around here a little bit, just to make it easier on me. Hopefully everyone has their, oh, there's one more slide here for us. Hopefully everyone has their trials up by now. Oh, that's the thank you slide. Spoiler alert. Let's hop into the actual environment. Hopefully everyone has a trial account by now. And if you don't, if you have any questions about that, please feel free to throw it in the chat. Kyle will be more than glad to help you guys out. Awesome. So folks, everyone, welcome to Observe. This will be the welcome screen, but I don't want to spend too much time on here. I actually want to get right into it. And the first place I want to introduce you guys to is the data set graph, right? What we've been alluding to of how everything is interconnected within Observe. So as you hop into your trial, make sure we go into the data set graph piece here and click on this little lineage view for us to get a good understanding, right, of what Observe looks like from a 50,000 view. So this is the graph where everything is interconnected and shows how the data sets are derived off of each other. As I mentioned before, we're going to be working off of the demo data namespace. So please go ahead and make sure we filter out to just demo data so we can see all that a little bit closer here. Right? So right off the bat, you can see that we provide a number of ready-to-use apps that sort of model common infrastructure and application environments, right? Things like AWS, as you see down here. Things like Kubernetes, as you see in our demo data sort of namespace here. Things like OpenTelemetry, right, for tracing and spans and application metrics. And as I mentioned in the terminology discussion, demo data is the data stream, but it also exposes what we call our source data set, right? So what we've gone ahead here and done is use the Kubernetes and OTel integrations to then derive these materialized views of important context behind OTel and Kubernetes, right? Things like metrics, log, traces, pod health, container health, and so on. Now, we'll get into the data graph a little bit more later on. For now, let's talk about today's scenario, right? Your mission, should you choose to accept it in this case. So for today, what we'll be doing is we're going to be putting on the hat of an SRE for a digital business, which is our astronomy shop and e-commerce website. And our team is responsible for ensuring the availability of the shop and responding both to regular on-call cases, as well as any pages if your customer success team gets reports that the application is going down or any potential issues. Today just happens to be one of those days. You've been receiving a lot of problem reports from customers, and they're indicating that the new and important "you may also like" feature might be broken. And when I say you may also like, I mean like a recommendation feature, right? You bought a table, you might also like a chair. No alerts have been going off yet, which is something that we must fix, right? Because if there's issues going on, we should probably have alerts on top of that. But we're going to do some initial triage within Observe anyways, right? So let's go ahead and get familiar with one of the first Observe Explorers that we're going to touch upon, which is our Logs Explorer. So on the top left of your screen, go ahead and click onto our Logs Explorer here. So we can gain view into all of the logs that we have within our platform right now. Now, just to give you guys a quick sort of lay of the land on what we're looking at here, the way Observe works and it looks like, it's pretty similar to other SaaS solutions, right? If you've had to grab your way through issues, this sort of view should be pretty familiar to you. So on the top left-hand side of your Logs Explorer is where you choose the source of the data that you're looking at, right? In this case, make sure we're looking at container logs coming from the demo data namespace. So we're all looking into the same context here and we can figure out what's wrong with our application. Now, on the bottom of that, we see filters, right, which really just map to the name of our columns, right, our sort of a tabular view, as I mentioned before, so we can go and filter into the values of those columns. So, for example, if I want to look into the logs coming from, let's say, the cart service container, I can click on that, and you see that the context populates right there, right, and in a couple of seconds here, we have all that context in mind, so just to showcase that. And then we have ways of filtering into every single column, as you see there. Now, as you select the filters, you can see that it sort of updated that so this dynamic query builder, and let's make sure that we're looking into our OTel or demo data namespace, right? Our OTel demo namespace, just to make sure that we're looking at all the same data. And a couple of things that I want to showcase to you guys here is that when we're filtering for specific information within our logs, Observer is going to do its best to sort of provide you common values to search for, right? So in this case, as I went into namespace, it sort of recommended me to look into OTel demo because there's a lot of logs within that namespace, right? And it just helps you autocomplete. It also gives you sort of a summary of the possible operations that you can do on top of your logs here, including things like substring search and so on. The one last thing that I'll mention for us here is that we're not sort of tied to this tabular view either. We can dive into what we call this chart view. And that's important because it's going to take us to our first quiz question of the day. The first quiz question, and the reason I've taken you guys to this sort of chart view is as a little hint, is how many containers in the OTel demo namespace are sending logs to AstroShop in the last 60 minutes? I'll give you guys one more hint. We can choose the type of function that we're looking at right from here. And we can also choose the type of visualization that we're looking at right from here, right? So instead of a line chart, I can look at it as table, single stat, and so on. So I'll give you guys 30 seconds or so to go ahead and get that out. Maybe 45 seconds, maybe a minute. Kyle, are you able to throw the question out to them, the quiz question?
Oh, that is my bad. I was typing to you, not. All right. So the first quiz question, as you go through it, and we'll give you about a minute to answer this, is as Lucas said, sort of how many containers are in the OTel demo namespace? And just another bonus hint. Yeah, let's show them. You can, everything in Observe is time series. And so this idea of sort of defaulting to sort of a timeline view is what we do. We're pretty proud of that. But summary is also something you may want to attempt to do. Just as a heads up. So we're going to give you 30 more seconds, but the question and answer is a poll or quiz in Zoom. So you just go in when it pops up and click the answer to it as you see fit. And if you don't feel comfortable answering, that's okay too.
That's okay too.
Ooh, looking strong.
Very nice.
I'm not going to say that is correct, but it might be the most correct. I'm just saying.
It's definitely the least wrong.
It's the least wrong. That's a good way of. There's actually some inside baseball there because things are time series. So the sort of rising and falling edge of things. I'm sure folks have dealt with this before. You can sometimes go a little bit above, a little bit below. That's why we say if you do a summary, that will be the sort of actual concrete summary over time. Cool. All right, I'm going to end it. Go ahead and show them how it's done, Lucas.
Perfect. Appreciate it, Kyle. So everyone, there's multiple ways we could have gone about this, and I'm sure you found your respective ways. You guys did get the correct answer, 15 containers. How would you arrive at that, right? A couple of different ways, as I said. So for one, we've already namespace OTel demo. That's great. We can change the visualization type to be a single stat, right? Which by default, what it'll do is it'll give us a single query value. But in this case, we're looking at a count of all events, right? What I really want is a count of distinct containers. Right. And that should take us to that 15 number that we saw before. Now, once again, we could have used this, we could have done this as a table. We could have done this as a line chart, but the answer is 15. So good job, everyone who got it right. Perfect. How do I close this quiz question now? There we go. It's gone. Awesome. Awesome. So as some bonus points here, we can also take a look at the, as I mentioned before, right, just to bring that into view. Anything you do in the UI within Observe is turned into Opal in the backend, right? So if I hop over instead of my builder view to my Opal view, notice that it's been written for us, right? So another way that I could have arrived at the issue or the answer here is just writing my own Opal, but I don't have to because Observe goes ahead and generates that for you as you play around with the UI. Cool. So now that we have a sense around building Opal queries, let's take it back to our scenario. So let's first of all quickly clear our query builder here. Go back to looking at just the raw data, if you will. One more point here that I'll put into place for us is that if you want to click this auto run button here, it'll make sure that whenever you make a change to the query builder, it'll automatically run that query for you, right? It's just a little quality of life change there that you can make. In our scenario itself, though, we're looking at a recommendation service, right? So one of the things that we can do, let's make sure that we filter into that service itself. Now, if you don't see the recommendation service on the left-hand side here, it's probably because it's getting drowned out by all of the data over the last, however much time. So go back to the past 4 hours on your date selector at the top right of your screen. And then we should be able to see the recommendation service show up here. So let's look for Reco. There it is, right? Recommendation service right up here. A couple of different ways you could go about filtering this out. You could use the filters on the left-hand side, right? But you could also just go ahead and write container equals recommendation service on your query builder, and it should take us there. So now that we've got this context into place, there's further filtering that we can do, right? So for one, we could make sure that we look specifically into our standard error stream. Now, once again, different ways that you could arrive at this. You could use the filters on the left-hand side. You can click into the value in your table that you want to filter for. We can see that actually our recommendation service is exclusively sending logs out to standard error. So really, there's definitely something wrong there. So now once we have this context in place, we have the full sort of view into our standard error stream. One thing that I do notice here, though, is that we have info logs coming out of standard error, which doesn't seem to be optimal. So for now, what I want to do, let's go ahead and filter into just the warning logs and do a substring search in our logs for that specific word. Right? So to do substring searches within Observe, it's actually quite straightforward. You take the column name, right, in this case log, and we use the tilde operator to do a substring search within the values of that column. Right? So in this case, I want to do a substring search for warning. And as I do so, what it'll do is, first of all, show me only the logs that have the word warning in it, but also highlight that word for us within all my logs. Beautiful. So now we have into view just all of our warning messages. One thing is that this might be worth aggregating on for us to keep track of any changes that we made later on to try to fix this issue to see if the number of warnings are going down. Right? So what we can do here is make use of a dashboard for the first time by adding a little widget to a dashboard that showcases to us how many warning logs we have at any point in time. So to do so, let's go back to the chart function and let's look at it as a single stat, right? And instead of a count distinct, let's look at it as a count of values of all events, right? So we have about 8.43 thousand warning logs over the last 4 hours. If your value differs, we're probably just looking at different timestamps. I see we have a couple new attendees. So go ahead in the chat and create a trial account, guys, if you want to follow with us. Kyle has put a link there for us. Just wanted to get that out of the way. But going back to our query here, we have that count, right? 8,500 warning logs coming from my containers. I want to add some information to this. So what we could do is we could choose a little label to add to this. I'm going to call it count of warnings. Right, and now we have that beautiful count there. Maybe I'll even change the color because 8,500 is not great. I'm going to make it red to represent that it's just not perfect. So just to show you guys, right, all the different configurations that we can change for our queries. We can change how it looks like. We can change the color by a threshold, by a value. Right? It's very flexible in the way that we do so. From here, what we can do is take this query value that we have and add it to a dashboard. Right? Now, we don't have a dashboard in place yet. So let's go ahead and create a new one. And it should automatically take that query into your dashboard. We can move that query around, drag and drop functionality. I just showcase you guys dashboards a little bit around. And let's name our dashboard Rico Recommendation Service. Why not? All right, just to keep track of that single point in time for us to keep track of our issue here. I'll give it 10 seconds or so for you guys to catch up here. And we'll keep going. One thing that I'll say to everyone, make sure we save the changes once we put these widgets in place, just because we're going to be adding more to this dashboard, and I don't want it to be sort of out of versioning with each other as we go along. So just make sure you save it, just have it in place. Oh, it seems like I already have a dashboard called Recommendation Service, probably from the other webinar. Let's call it Recommendation Service 2. Beautiful. There we have it. Awesome, everyone. So now we have a place to lend evidence as we continue to investigate, right? So let's go back to trying to figure out the issue here. What we'll do now is we'll actually use our Logs Explorer to pivot to what we call related metrics, right? But first, let's make sure everyone's zoomed out to the last 4 hours, just so we have as much good data as we can, right? So once again, to zoom out, go to the top right hand of your screen and just search for the past 4 hours, right? I'm going to exit this visualization view that I have here, go back to the raw data. And once we've pulled, sort of the back 4 hours of data, what we could do is use Observe's correlation engine to go ahead and dive into this underlying container here by double-clicking just the name. What that'll do is it'll open up a little side drawer with all of the metadata behind that container, right? Including image, ID, restart count, because it's actually restarting quite a bit here. The state of this container, the reason, right? And we also have a sort of correlated tab here, which takes us to the metrics of that container. So one of the things that I want to check for is to see if we have any memory, any resource contention going on here. Maybe my memory is spiking, maybe my CPU is spiking. So what we could do is just do a little string search here for any memory metrics, right? And we see here, container memory usage. It's all right, not perfect, not great. What we could do is we can actually dive into our metrics explorer right from here, right? So if we click on this, what would you call it here? The square with an arrow, it'll take us over to our metrics explorer and showcase that time series for us right from here, which we can then play around with and sort of change the representation to add to our dashboard later on. So one of the things that I want to do perhaps is look at my container's memory usage, throw it into my dashboard, and maybe even create an alert on top of it. Now, one thing that I'll mention as we go through this is that the context of that container that I was looking at carried over, right? So now we're looking at the metric with my recommendation service container in there. And this is super vital when you're trying to respond to an incident where you don't really clearly understand the root cause of the issue, right? Being able to follow that trail of breadcrumbs as you go through your troubleshooting process and taking the context of one view to the next, super powerful, right? If you're an engineer trying to just figure out an issue out. As an aside, right? Opal is once again generated for us. So just tying back to what I said before, if you want to be a regular user of Observe, you don't want to dive too deep into Opal, you can just via the UI. And if you want to be that power user, you could totally dive as deep as you want within Opal itself. Now, we touched this upon sort of the initial architecture discussion, but I just wanted to reiterate a little bit for the folks who have lived this. It's always difficult, right, in terms of Opal or any proprietary query language, really, to adopt a new domain-specific language, right? But the biggest difference within Opal, as I mentioned before, as I alluded to before, is that it works across all of your telemetry, whether it be metrics, logs, traces, business contextual data, CI/CD events. It's a single unified way to sort of query across the 3 pillars of observability, right, and more, and much more. Many organizations nowadays are having to deal with, using SPL for Splunk, PromQL for Prometheus, maybe some Elastic Query language, right? Maybe some SQL for the business types. In this case, no, you have one language, Opal, and it allows you to do everything sort of in one unified fashion. So now with that out of the way, right, the context out of the way, let's go to our second. Oh, Kyle, thank you. Let's go to our second quiz question here. So now that we're in this, right, go back to the builder, just make it easy for you guys. Now that we're in this view, the question is, once again, in the Hotel demo namespace, what 3 containers have the highest memory usage, right? So use everything we've taught you so far to go ahead and find the 3 top containers with the highest memory usage. But once again, within just the Hotel demo namespace. So just as a hint, right, let's make sure we remove the context of the recommendation service and namespace ourselves to Hotel demo. So I'll give you guys a solid 20 seconds there, maybe 30 seconds to go through it.
Yeah, we can give them maybe a solid 30. I think that's fair.
Okay.
And just in your case, do your best. You can see that this is a pretty wild environment, as Lucas actually alluded to at the top of the call. So this is a live implementation of the OpenTelemetry Hotel demo. So this runs that same set of services that are distributed. And so the only thing that's always true every single time we run this hands-on is that Kafka is like a total memory hog, but that, it's doing a lot of work. That's okay. What I will say is that some things might jump around or whatever. Do your best to answer the question. We'll still give you the certificate at the end of the call. So right on. Okay, well, we're gonna give it 20 more seconds, folks. And so as Lucas alluded to earlier, or said earlier, sort of what are the 3 containers with the highest memory usage? Also, another fun fact, so we have basically we're connected to the head of the actual Git repo for the demo. And so sometimes this stuff just changes because we'll just do a pull and deploy, which is obviously like a cardinal sin in the world of DevOps, but YOLO, I guess. So cool. I'm going to end the poll and you walk through the answer.
Awesome. So a couple of different ways. Once again, everyone, we probably could have arrived at this. I see some great answers here, and Kafka is in both of them, so that adds up. First things first, let's make sure we namespace to Hotel demo, right? As we talked about before, run that query. So now we're just in Hotel demo. And now first of all, we could do this in a couple different ways. Just, for example, brute forcing it by looking at it and try to find it. Notice that the values do change. So depending on your time frame, you could have one answer. You could have had another time frame. But one way that we could have gotten at that is just look at a sort of breakdown of the sum by container, right, over the last, let's say, 4 hours here. And that would have given us Kafka, ad service, load generator, which really doesn't count. I mean, it's just generating load. But then any one of those other services, right, would have been an acceptable answer here. The whole point that we were trying to get to is just make sure that you're doing a sum by containers, right? And sort of aggregating it by what you're looking for to give you that answer. But one thing that I'll sort of mention here, going back to our troubleshooting scenario, is that it might be hard to see, but our recommendation service is not doing too hot, right? It's a little squirrely compared to the other metrics. So one of the things that we can do is sort of just dive into it, right? We can click that recommendation service name. We can click on the time series from our recommendation service. Might not be as easy as it looks. So let me just filter us out to recommendation service. There we go. That should make it a lot easier for us. There it is, right? It's looking a little squirrelier. You could have done this by clicking on the time series. There's just a lot of data there, so it becomes a little harder. We could just filter out a little bit more. But what I want to do with this now is two things. I think that it'll be worth adding this to our dashboard, just so we can keep all of our sort of investigation steps in one place, right? So similar to what we did before with the query value for our number of warnings, we can add this to a dashboard just by clicking the top right-hand side of your screen, right, in Actions, and then Add to Dashboard, Recommendation Service 2, or whatever you named your dashboard in that case. And then if we go back to it and refresh it, there it is, right? We can see that our new time series is right here, beautiful in place for our investigation. Awesome. Now let's take advantage of what we have here already so far, and let's create a monitor off of it, right? I mean, just going back to the troubleshooting scenario, the only reason we knew things were going wrong is because our customers were letting us know. So let's remedy that right now ad hoc and create a monitor so that next time we know that this is going on without the customer being affected for a long time prior, right? So one of the things that we could do is, once again, instead of adding this to a dashboard, it's just creating a monitor for it, right? And once again, Observe is going to take the context of the time series that you're looking for and then throw it into a monitor for you, so you don't have to refine that context, right? Everything carries across your views. So this is the monitor creation page, just to give you a little lay of the land. We have a time series of that metric over however many hours you're looking back. We have the query for that metric, which we saw before. So our namespace Ulta demo, recommendation service container. It's a sum of its metric averaged over 30 seconds. And then we can create our alert conditions, right? So everything is a nice little, we have a nice little GUI here for everything. We can choose the status, or I guess the severity of this monitor, right? Whether informational or important. We can change the type of thresholding that we do, whether it be when the metric is equal to a threshold, greater than a threshold, less than a threshold. We can change how we evaluate when it goes over that threshold, and then how long for it to be above that value, right, when we alert you. One thing that I'll mention here is that while we're looking at a static threshold in this case, we can, it's more than possible. It's expected that you can create dynamic monitors, right, based on a specific metric, just by using things like a moving average or a standard deviation, right? And we can create those sort of more dynamic thresholding monitors for you. For the sake of simplicity, let's just keep this one static, and let's choose a decent threshold for us. So we can see here, memory rarely goes over this sort of 40 megabytes range. So let's put our threshold at around that value. The thing is that since we're going to be dealing with, I believe, just bytes here, we're going to have to add quite a couple of zeros, but this should take us there, right? About 40,000 or 40 million. Yeah, 40 million bytes should take us there. Ends up at about 38 megabits, seems like. But we see the threshold being generated there. And one of the things that I'll do here is change the type of thresholding just to show sort of a different representation of what the monitor would look like, right? So in this case, instead of having to stay above that threshold, I want to be alerted when my metric crosses that threshold at least once. And one of the things that Observe will do is highlight for you in that time series when that monitor was going to trigger, as well as show a preview of when this alert would have happened as well. We could also add different notification actions for this, right? We can go ahead and throw a webhook to your favorite communication collaboration tool, create a Jira ticket, right? Whatever you want here, webhooks, quite flexible. But once we have this in place, let's go ahead and save it. Oh, seems like I already have a threshold monitor in place, which is good. That's a pretty generic name. Let's go ahead and call it a recommendation service, a Rico service monitor. Hopefully that one doesn't exist yet. There we go. Right, so now we have a Rico service monitor in place. Kyle, I saw you threw on a quiz question here.
That was my fault. Yeah, sorry.
Okay.
I forgot to close the last one because it moved the
I see.
close screen.
Nah,
So
no worries.
yeah.
No worries. Just wanted to make sure I wasn't missing anything there.
No, you're good. You're good. Yep.
Cool, everyone. So we've got our monitor in place. So if you want to take a look at it, let's just hop over to the monitors tab. And then we should see there, actually I have quite a bit of monitors for this, but the latest one was just Rico monitor, May 9th, right? And you should be able to see something similar. You can go ahead and I believe click on it as well. Maybe not here. Anyways, there's our monitor, right? We can view the alert. There it is, view the alert. And it'll give you sort of all the context behind that. But awesome. Cool. So let's take a step back here. We've fixed this problem, or of not having a monitor, that is, right? We have a dashboard, we have our monitor in place, we'll be alerted next time. So now that we've investigated logs and metrics, I think it's only fair that we move on to traces to see what the customer experience might currently be feeling like for our customers, right? And no better way to do that than to look at the requests that they're making to our website and how long they're having to wait to receive an answer to them. So if we pivot over to our Traces Explorer, it should be fairly similar to what we saw before. Make sure, if you have no data here, that you're looking at the demo data / OTel data set. I was playing around with some open telemetry earlier today, and I was throwing data into the sandbox. That's why I was in the other one. But you should be defaulted to this one, so I'm not too worried there. So once you've navigated to traces, let's expand our search to the last 4 hours once again, just to get us some really good data to our platform here and within View. And by default, notice that there's we're filtering out your spans to service entry points, right? Meaning the first call to a specific endpoint, not necessarily the subsequent calls made from there. Just to facilitate, it just facilitates. I mean, if you're curious, you can go ahead and remove that filter. It's going to be a lot more data in your screen. But by default, we're sort of scoping to that. What we can do now, though, is quickly look at all of our error traces, right? With the click of a button, we filter out to only response status of errors, and then we see all of those calls, and there's actually quite a bit of them. Quite a bit of errors going on here. We'll take a step back here, though, take a little break for another quiz question. Let me think of any context that I can give to help you guys before we dive into it. And now this one's easy enough. There's a couple of ways to get there, and it's gonna be a challenge for you guys. So the quiz is, how many? Question 3, right? How many and what are the names of the services that we have error traces for? So notice that we're already scoped into response statuses of errors. Notice that there's a couple of filters here for services. I'm wondering, is there one filter here that would help them, Kyle, get there? Should we be scoping into the namespace of demo data or OTel demo, you think?
We can do that. There's a few different sort of quick paths. I think what we'll do is let's give them 20 seconds. I think you gave some very, very ample hints, so I appreciate that. And then we can pivot from there.
See what we got here. Okay.
All right,
nice. Nice.
There might be a subtle trick to this one, so we'll see. So,
yes.
But that said, let's have you take it away. I'll end the poll.
All right. Beautiful. Okay. A couple of different ways we could have gone about this, right, everyone? So for one, just by clicking on this little filter section here, we would be able to see all of the services that we have errors for, which is awesome, right? It's already filtered out to that. A couple of other ways we could have gone about it is by looking at the filters on the left-hand side. Or even if you're feeling very adventurous, write some opal, right, for it. Now, I'm not going to do that here, but it is one of the ways that we could have gone about it, right? Just doing a little make column or create a table view or a time series, right? Whatever floats your boat there if you're feeling adventurous. But the next question is sort of tied into the same sort of context here. Which service out of those 4 or 5 in this case have the highest number of client errors, error traces in this case? I'll give you guys another 30 seconds or so, 40 seconds to get that one out. There's a couple of ways you could go about this. You could brute force it. You could find something that I haven't shown you yet. Or just create a time series, bar charts, whatever you want to do. Nice answers so far. Is certainly the least wrong.
The least wrong, for sure. I also, I feel bad. Most front end teams, if you have, sorry, apologies to folks that aren't back end teams. You work hard too, but most of the time, right, the way that your customers interact with whatever services you provide is through the UI. And so usually that's where they propagate up, but it's not always front end's fault. And I'd actually argue it's very rare that's truly the case. But for front end folks are like, you come into this display and like you're the biggest slice of pie on the pie chart. You feel a little bit bad. So
It seems pretty targeted, Kyle. Do you have some previous beef with front end folk?
no. As somebody who's incapable of writing any sort of quality front end code, uh, I think they get blamed unduly. All right, cool. So answers are
Awesome.
in. Let's take them through a way to get there.
Yeah, for sure. So, folks, a couple of different ways, right? For one, you could probably just bat an eye on this and see that a lot of them are coming from front end, right? On the other hand, we could try to use the filtering approach, and Observe will always show you sort of, a little bars showing just how many of each value is found within that column. But the best way I would say, I guess the most correct way would be to group this little sort of, we have some red metric bar charts here, right? Requests, errors, duration. We could group that by a specific service, right? Group the error time series by a specific service, and we'll see that by far and large, the largest share is coming from my front end service, right? So once again, just a couple of different ways we could have arrived at that issue. Observe gives you plenty of different ways to arrive at the same result. That being said, going back to our troubleshooting scenario, we can immediately tell that our customers are just not having a great time, right? Just given the sheer number of errors coming from front end. That said, let's take a step back. And since we didn't see any errors being emitted from recommendation service, which is weird, right? I mean, it's what we were seeing on our container logs. What else might be going on here? So let's do this. Let's scroll out to the attributes column. It should be here towards the end. So if you just scroll in our table view all the way down to the attributes, one of the things that Observe is quite powerful about, and honestly, one of my favorite features is the ability to manipulate your data within the platform, right? So we talked about the sort of the data lake architecture and being able to receive any sort of data, whether structured or unstructured. Here's a great display of how we use that power to allow you to sort of transform it post ingest, right? So scrolling over attributes here, if you click on the header of this column, we can see it's a bunch of JSON objects. We can extract from JSON, right? So what Observe will do for you is it'll look at that object, right? Find all of the attributes within the object and tell, hey, what do you want to bring into view here? And that's what we call schema on demand. So in this case, what I want to bring into view is my HTTP target attribute. So if I select that and then I click apply, what it'll do is schema on demand will take that attribute and on the fly modify the schema of my table to introduce us that new column, right? That's quite helpful for us to identify which endpoints are being hurt by this. Now that we're here, I'll give you guys about 10 seconds. I'll give you guys about 10 seconds here for us to catch up, but we have our 5th quiz question. So 10, 9, 8. Cool. Here's the 5th quiz question. So once we have this attribute in place, the question is, based on this HTTP target field, what 4 services are being impacted, right? So using this newly related field that we just brought into view, which 4 services are being impacted? You guys about 30 seconds to get through it.
Yeah, one of the favorite things that we did recently, this is going to sound super nominal, but because we talked about front end earlier, if you scroll left and right on a newly extracted field on a column, we'll actually re-highlight it for you. So sometimes it gets a little bit dicey trying to remember, like, okay, I just added a new column or I removed it or whatever. And so we get a blue dot, of course, too, but there's usually a nice little sparkle effect we layered on top of that recently. So
today I learned.
That's right. All right. Ooh, a variety of
Nice.
answers. I like this. All right, let's take them through it.
Take them through it. Yep. Cool. So everyone, once again, a couple of different ways we could have gone about this. In my opinion, the easiest one would be sort of just bat an eye on it if you do a filtering approach. And we can see, right, we have a product endpoint, we have a recommendations endpoint, we have a checkout endpoint, and then all the way down, we have a data endpoint, right? Which I'm not quite sure what that's doing, but it's there and it has errors attached to it. So we should probably investigate it at some point, but that can go in the backlog. So if you said checkout, data, product catalog, and recommendation, you were correct. So good job there. So what we'll do here now, let's filter into our, sorry, this the question window keeps popping back up. Let's just filter into our recommendation sort of endpoint here, right? Because, it's generating front-end errors, or it should be, by people making calls onto it. So let's apply this filtering here. And let's take a look at all of the HTTP targets that are just for API/recommendations. What we can do here now is that we're not triggered, we're scoped into my recommendations endpoint. Let's go all the way to the left, and it allows us to, oh, we don't have to go all the way to the left. I didn't notice this, but the view trace button is frozen in time so that we can dive into whatever row we find. We can dive into the underlying trace view for that, right? And you should, you could be familiar with trace views, but just to give you guys a lay of the land here, it's just going to be a flame graph of the HTTP call stack, right? So someone made a request to that first endpoint that we saw, which then called down to my recommendation service. And one of the things that Observe will do for you is highlight the spans that we have errors for, right? As well as bring into view, hopefully, the stack trace. Where did my stack trace go? Span events, maybe?
Yeah, it's also possible.
There it is.
There we
Yeah.
are. Hey.
Yeah. So just a quick warning, guys. If span event says 0, click on it anyways, because it'll update to show if there's any errors there. We should probably go take a look at this guy later on. But one of the things that the tracing will do, which is awesome, is it'll highlight where you have errors, but also give you the metadata behind that error, right? Which in this case, if we double click it, is the stack trace of that problem, right? So we can see that sort of spike in memory that we saw in Metrics Explorer, it's very likely triggering an out of memory, right? Where we can't connect to my backend anymore. Thus killing the service and sort of making it available for the front end. That's why we have all those front end errors, right? So our front end is trying to call our back end, it's not able to, and then it comes back with an error, which looks like a front end error. So it looks like we can, at this point, pretty much fully confirm the user reported issues. All we'll need to do at this point is probably just page out the team that owns the recommendation service, come up with a fix, and then in the meantime, we can sort of bump up the memory limits for my backend infrastructure so that it stops going out of range where it's failing. From what I remember, about 80 megabytes should do the job there. The thing, though, is that if we hop back into our Explorer, right, if we click on this little back button and get back to our traces, it seems that there's additional errors that we're seeing across a few different services here. And we can sort of continue through this Trace Explorer to get a better picture of what is going on, right? So close that flame graph view. Let's remove this recommendation service HTTP target because we're already done with it, right? We've confirmed that that's something going on there. So let's get out of there. What I want you guys to do is to use one of these filters to look at a minimum duration of your traces of about 15 milliseconds, right? So on the left, on sort of the filter view, go ahead and do a minimum of 15 milliseconds for us to look at those slow calls, right? Not that 15 milliseconds is slow, but this is for the sake of the story here. So once we're filtered into all of the traces that are above 15 milliseconds duration, we can see that there's still recommendation issues here, but it looks like our checkout service is being uniquely impacted as well, right? And that's not great because that directly impacts our revenue as an e-commerce application, right? So let's dig into one of these traces, right here. Anything that says status code 13 should be pretty good. Let's dig into one of these to see what that 13 is all about. So we can see that this trace is a little bit more complete than the others. We have more calls, we have more context, which is great. You guys can explore that if you want. I think it's an awesome little view here. But in this case, to quickly reach into the root cause, we can simply just click on the first occurrence of an error. And I love this, right? We can just click on the first occurrence of an error within my flame graph view. And then Observe is going to go ahead and highlight that for you of what that error is, right? Now, in this case, it just turns out that we had a feature flag to go ahead and fail. But just like a real deployment, right? It might seem like a pre-canned process, but just like a real deployment, I mean, you start off seeing front-end errors, you go into your traces, you find something weird, you hop into that trace, and then just by looking at the first occurrence of the error in your backend, you'll be able to get a pretty good idea of what's going on, whether it be an error message or the stack trace, right, at that point in time. Now, we can always disable this feature ourselves, right, to remove one error path for our users. But that sort of concludes the first troubleshooting part of our of our flow here. We're going to shift gears a little bit, and we're going to go towards sort of what we call our first challenge, right? And for that, we're going to hop back into our Logs Explorer view, still using our container logs demo data set, right? Container logs demo data, make sure we're using that source of data. What we'll do at this point is let's go ahead and filter into our controller application. All right, so our controller container. So with the click of a button, you can get there. And let's pretend for a moment that we never had APM in place, right? Because the way we found our error in the last problem, the way we sort of got to that root cause was by looking at our traces. Not all teams out there are fully fleshed out with their telemetry in terms of APM. So how could we arrive at that same sort of context just via our logs, right? In this case, ingress logs from our web server, in this case, Nginx. We can actually get pretty far with just this information by taking advantage of what I talked about before, which was schema on demand and schema on read, right? On the log column header, if we look at this, our sort of web service, our web server logs, what we can do is, if we click on the column header, is do what we call an extract from string, right? So unlike perhaps other observability solutions in the market, we don't have to create a pipeline for our logs. We can use the schema on read functionality to go ahead and modify, once again, what we're looking at with the information that's within my logs, which once again, doesn't matter how you send them to us, we're sitting on a data lake, we can play around with them. So what we'll do in this case, we're going to write a regex to go ahead and extract the information from here. So if we click on this generate regex button, Kyle is going to go ahead and paste the regex for you guys in the chat, just in case, we can't get it done via the Ollie GPT assistant here, which I actually should talk about, right? Ollie GPT is sort of the baked-in Gen AI that we have within Observe, where it'll act as not only your AI assistant, but it'll also help you with sort of these not menial tasks. This is certainly non-trivial, but it'll help you with generating regex, generating opal, right, and just assisting where it can. So once again, Kyle posted in the regex into the chat, just in case for some reason this button doesn't work, which it should. But once I click apply, what it'll do is it'll extract as much information from my log as it possibly can, right? Things like the address, the date of the call, the method of the request, right? The URL that we're hitting here. And number of new columns there, which were highlighted in green, as Kyle pointed out earlier on. Now, the two most interesting columns for me here, which sort of give me a sense of application monitoring, are two. It's the URL that we're hitting, right? The endpoint that we're hitting here, and the status code. So one of the things that I want to do is I want to extract some information from my URL by doing the same approach that we did before and performing an extract from string. Once again, Kyle's going to go ahead and post the regex for us into the chat. The biggest difference here is that, oh, I wonder if that'll work. Let's click apply.
Let's check it out.
Yeah.
So the we're regexing a regex, which is kind of, I find that to be totally wild. The other thing I just noticed is it looks like somebody's using some sort of scanning bot, I think, based off of the URL. Oh, there we go. Perfect. So I would highly recommend using the backup regex I pasted in the chat. But functionally, if you look at the URL that's in there, that's not sort of what I call traditional application traffic, which, the great downfall of regexing your regexes is when someone inserts.
Absolutely. And the whole thing, using LLMs it's incredible. If we were to just scope the data into a little bit more similar endpoints here, it'll work perfectly, right? It's just that we're looking at across a lot of different contexts here. You can see there's a couple of different types of URLs where it does its best, and you could probably build off of what it gave you very easily. But in this case, right, we have the pre-built regex here. Why not just use it? But just to get back to the story, right, we now have a new API endpoint sort of column, so data, and then we also have a status code next to it. And if you put two and two together, that gives us a pretty good understanding of the performance of each one of my endpoints that I can then create a metric to alert me on top of. So essentially what we're doing here is deriving application-related metrics just via my logs, right? So what we can do is let's go ahead and aggregate on these status codes, including the null ones, by simply clicking the sort of visualize button, and this little, not visualize, but chart button in this case. So what it's doing now is it's doing a count of values, which is fine, count of all events. But what I want to do is I want to break this down by URL first, so we can run that, just see what it looks like. Pretty messy. But then we can go ahead and add status code. Run that again. So what we're doing now, we're effectively, let's visualize this as a bar chart just for the sake of simplicity here. Beautiful. We're effectively looking at the performance of each one of my endpoints as a metric. And one of the things that I'll highlight is that first, we have an instrument in our application. And second, I'm adding two pieces of cardinality to this metric, which if you're using most observability solutions in the market today, right, this would be considered 84 custom metrics. Within Observe, this is just data, right? There's no extra charge for what we're doing here. This is just a metric that you're deriving, and it's just present within your logs. So we're extracting that and generating this for you at no extra cost. Me, as someone, just as a side point here, someone who comes from Datadog, great product, but the custom metrics there are scary, complex. This is very simple. No baggage associated with it.
Love it. Also, if you want to show them, so obviously, one of the things you did is you extracted status code as part of the initial regex. If you swap URL out for, I think we call it API. I think maybe it's API endpoint.
Oh, API endpoint. Good call.
And so slicing and dicing the data
there it is.
Can be as sort of complex or as simple as you want it to be. And regex is like a classic tool that everybody I'm sure on this call has had to use at one point or another. So we're doing the Lord's work trying to make that a little less onerous. I still, however, will continue to have bookmarked regex101.com for testing these things. I'm sure one day the AI overlords will figure it out, but today is not that day. So
yeah, it'll get there at some point. And look, it's already made a lot easier than it used to be, let's say 5 years ago.
100%.
Awesome. If we want, we could also, just as an aside here, we could change the time, the aggregate, the time that the resolution is what I want to say, right? So that instead of aggregating this every 30 seconds, it might be more helpful to aggregate this, perhaps every 5 seconds or every minute, right? It's completely up to you. We just give that flexibility within the platform itself to look at your metrics sort of as granular as you want. So just to recap, right? While having full spans and traces is optimal, we can actually take something as simple as an ingress log from your web server, just to see how our services are doing, and then go ahead and alert on top of this, right? So we've already, confirmed that there are some serious health issues within our recommendation service. But if we didn't have that data in APM and we were in a pinch, Observe can actually just take commonplace data sources like ingress logs and transform it into something that's pretty close to APM. Now that we have this view into place, we're going to go into our quiz question number 6. It should be, which APIs are throwing a 308 status code, right? So once again, which APIs are throwing a 308 status code? Just as a hint, the answer is in front of us, but there is ways that we could make it a little bit more obvious just by playing around with the visualization.
Absolutely. Yep. And because we took the time to break out our status code as a distinct filterable value, you could even look at doing something like that. So we'll give you all 30 seconds or so to answer this question. Something else that you touched on, Lucas, and I think it's really important just to talk from our experience and working with a number of customers, especially in the last year, is there is a cost piece, as you mentioned. And so because we treat everything functionally as just sort of data that you can bend to your will, and we obviously have first class support for the 3 pillars of observability, logs are ubiquitous, right? And to go from logs to distributed tracing is a journey. Like customers are either at 0.0 or maybe they're 100% there. I don't see that super common, but it's really, really, we believe, important to say, hey, let's take the data you have and let's build something that everybody in your organization can benefit from, whether or not you've done everything, you've auto instrumented everything via OTel, or we've spent that time. That's hard. That's additional work on top of delivering actual new features to the services you already own and maintain. So this is why we do this exercise, is just to show everybody, like, look, there's actually a way to get a tremendous amount of value out of stuff that's just kind of sitting in the background as sort of digital exhaust. So, all right, let's end that poll and let's, hey, show them that shortcut. Let's see how it goes.
Show them the shortcut. Oh, which shortcut? Okay. So one of the things that we could do is wait 1 second. I'm trying to, what was the shortcut now? Kyle.
Yeah, if you move, sorry, you're good. If you move status code into the filter bar, so where it says container equals
Yes,
controller, if you do
yes,
status code
yes.
equals
I thought it
308.
was
Yeah, yeah.
thought I was missing something for a second
No,
there.
no, 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 you're
But
good.
yeah, everyone. One simple thing that we could do, right, is that we know we're looking for a 308 status code. So we could just do a search on top of it. And then it would just highlight all of the endpoints that have a 308 status code. The other way we could have arrived at that would just simply be by looking, probably how a couple of us arrived at it, is just by looking, and we could bite an eye on this and see where we're at. We could have used other visualization types, like looking at a table, a list, right? A couple of different ways we could have arrived at it. Last thing I'll highlight is, once again, all of our regex, all of our visualizations, all of our filtering is transformed into Opal in the backend here. So for everyone who said all of the above, that was correct. Good job. So, well, we're at the end of our troubleshooting process. So congratulations. We've sort of successfully navigated our scenario. And we discovered that two of our services were causing customer issues, and now we have a path to resolution. We do have one last exercise, as I alluded to before, and this is this is something that's very much unique to Observe's approach to observability, right? We're going to do what we call data shaping and turn some of our observability logs into business insights. And it's a lot of fun, and product managers like Kyle love this functionality. Now, this will touch on a number of new concepts, so feel free to ask questions in the chat if you get stuck, if you need help understanding something better, clarification, and so on. So let's hop into our bonus challenge of using worksheets. Now, understanding things at the service layer is essential to getting ahead of, as well as fixing problems, right? However, anyone who's been in charge of a sort of ensuring uptime for a service, whether it be monolithic, distributed, otherwise, knows that one of the hardest sections to answer during, let's say, a post-incident review, a post-mortem, is the assessment/evaluation section, right? Particularly understanding if, from what you have, from what you had available to you during the incident, was that adequate to solving the issue? Now, rather than starting in our explorers, we're going to go to our datasets page, and we're actually going to, our hands dirty with some pretty good Opal. So if we hop over to datasets, we're going to be looking for our sort of base data set for the demo data namespace, right? So if we just, once again, navigate to datasets on the left-hand side of your screen, and then scope into demo data, and make sure we do demo data name. I forget the differentiation here, Kyle. I remember you explained it once, but I forget as to the difference between these.
Yeah,
Just make sure we're on the, yeah, go ahead.
I was going to say, so the way that we sort of sort things and namespace them, there's a special namespace called no package, and that's the one we want. So when you see no package and observe, think of every data set that's not packaged, almost always is going to be tied to that data stream that Lucas talked about in the architecture slides earlier. Think of it this way: we're dumping observability events into the central location. That's what we call a data stream. And then you can create data sets off of that. But every data stream has a sort of a root data set, right? Or a base data set is what we actually call them. So that's why we say look for no package. It's so you don't get into a pre-shaped piece of data. That's all. Yeah.
Makes sense. Makes sense. Awesome. So now that we're here, we scoped into it. Don't click on the data set itself. All the way to the right hand side of your screen, there's going to be an option to open this in a worksheet. And a worksheet is sort of like a playground, right? You're a sandbox when dealing with any sort of data sets within Observe, whether it be a no package data set, as Kyle just explained, or an already populated, already transformed data set. So once you open this in a worksheet, you should be taken to a view sort of like this, where you have that, once again, your tabular data. We have your query builder at the top, right, top of your screen. But then we also have an Opal section that we can write Opal with, and sort of our in page IDE, if you may, to writing some Opal. Now, as Kaya mentioned, there's going to be quite a bit of Opal that we wrote here. So he posted a link in the chat that takes you to sort of that pre-built Opal. What I'm going to do with you guys is I'm going to go line by line on this Opal, and I'm going to showcase how it's transforming the data. Just make sure I get the right information here. So once again, go ahead and click on the link in the chat. It should be a tiny URL with the Opal pre-written there for you. Just copy and paste it into your Opal sandbox here, or your Opal window. And then we're going to go line by line, understanding what this is doing to your data and how it's shaping it. So again, if I run this, nothing should change. I have my sort of raw data there. What I'm going to do is I'm going to go back to 24 hours just to make sure I have as much data as possible. And then we're going to go line by line, right? So what the first line of Opal is doing, it's creating a column named tag, and it's filling it up with information that's within my extra column, right? So in my extra object, the tag attribute is being transformed into a tag column. So I'm going to go ahead and run that. So we have is a new column tag. We can see that it's all null, but that's okay. It's just because that there's so much data within here that what I want to do is I need to go ahead and fetch that data from all of my, so there should be almost 70 million rows of data here. We can say that once I fetch from everything, then that product catalog shows up. So there we have it. So then what we'll do is we're going to go ahead and filter specifically into that product catalog, right? So filter tag equals product catalog. We can see that these rows are coming into view. As observe is sort of parsing those 70 million rows very fast in about 7 seconds here. What we'll then do is create a new column called products, which is based off of a fields object, or I should say a fields column within a products object. And there we have it, right? Our new product column, it's here. One thing that I noticed though is that it's currently an array, right? Which honestly goes back to what we talked about before. It doesn't matter how you send the data to us, we can shape it after the fact. Where so we even have an array of JSON within Observe, and that's honestly pretty cool in my opinion. What we need to do though is flatten that array so we can then access the objects within it and transform each one of those into a column itself, or a row itself, I should say. All right, so now we have all of that into view. Finally, we're going to take all of that information that we just went through, and we're going to parse it into different columns so that we can access them a little bit easier. Right, so within all of those JSONs within that array, what my Opal is doing here is it's accessing them, since we just flattened it, and then creating new columns based off of the attributes within those JSON. Then we're going to do some operating on one specific column, which is price, where we're then going to have to add two values, units and nanos. Nanos just being cents in this case. We're going to make them into a string, concatenate them. That's to show the power of Opal here. Concatenate them, turn them back into a float, and then round them to the nearest cent. So what we should be able to see here is the price of each product that we just derived from two strings. Finally, it was really where the magic happens in this case, is we're going to take all of this data and we're going to transform it into a resource data set so we can track the state of my products across time. Things like changes in price, changes in description, right? We're basically going to be creating a product catalog in this sort of format here. We have the product name, we have the price of the product, the currency it's in, the categories associated to, and the description of it. Beautiful. Finally, we're going to set a primary key, or I should say a label to this product data set, which is based off of the name. All of this does, everyone, is that when I reference this data set within a different one, this is what it's going to bring into view, right? It's going to be the name of the product, right? So it's creating the label is based off the name column. So with all that Opal, right, just to recap what we did, we went from the raw data, which was this, into an awesome resource data set that showcases all of my products and it's tracking the state of them across time.
I just want to say again, as product manager, really loving this.
Awesome. I mean, you came up with it, right? So I hope so. Cool. So everyone, once this Opal successfully runs, once we have something into view like this, go ahead and rename this query, right? So on the top left-hand side of your screen, you can see as we do new queries, it's going to create sort of new worksheets or new windows into your worksheets. Let's rename it. Right at the top, I'm going to rename it, what was it called? Astra Products. It's probably going to give me an error because I definitely have an Astra Products already. So I'm going to call it Astra Products 5. Beautiful. If we want, we can go ahead and save that worksheet. I recommend doing so, right? We saved it. But then what we could also do is publish this data set, right, as a new data set. So what this will do is just make it permanent, right? So other people can access and reference to it and relate back to it. So once I publish it, I'll rename it to Astra Products again, so we can identify it. See, I'm going to call it Astra Products 5, just to make sure we're there. Click publish. And what that'll do is it'll make that data set, that view that we just created, permanent, so we can reference it back. So with our new data set created, let's go back to our data set view. Let's search for Astra Products 5. Notice that there's 1, 2, and 5 now. And there we have it, right? It's currently initializing. Observe is sort of spinning up its gears. It's warming up the engine. to create this resource data set for us. For the next step, though, we're not going to stop there. Let's go ahead and look for container logs scoped into demo data. All right, so search for container logs. Make sure we're using the demo data package one, not the Kubernetes one. We've made some changes. We can see this one actually has data in it too. And let's similarly open it into a worksheet view, just like we did. Now, what we're going to do is we're going to predominantly use the UI to build the Opal here, just to make sure that we're used to that too, and to make things a little bit quicker. First things first, let's go ahead and filter into my cart service container. So going into the container header, make sure we're looking at cart service, click apply. It's going to bring in the filter into view for us here. Now, once we're here, we want to extract some information. I guess you guys can kind of see where we're going with this, right? We created a product catalog, and now we're looking at our carts. Let's hop into the log message, and let's do an extract from string. But instead of using regex this time, we're going to do one of the pre-built parsers that we have for key value pairs. Right? So we're going to try to extract some key value pairs from this. So once again, column header view, extract from string, key value pairs. Click apply. Observe will do its best to go ahead and try to extract any key value pairs that it identifies from your log messages. Build it into that new sort of KV pairs column. Now we're going to do one more extraction here, but this time we're going to take advantage of the JSON structure of our new KV pairs column, right? So once again, go into the header, do an extract from JSON, and let's extract all 3 fields from that column and bring them into view for us here. All right, so there we have it. Product ID, quantity of products, and then a user ID as well, which is really nice because we can now tie back in how much each customer is adding to their cart in terms of product value, right? Because we have that information now. Just to highlight that again, the Opal is built for us via the UI actions. So that's super helpful. And now that we have our 3 new columns here, what we're going to do is we're going to use the power of graph link, the correlation that Observe creates across everything, to correlate this data set to our Astra products data set that we had before. So on the ellipses here on the top left-hand side of your screen, go ahead and click on link to other data set. What that'll do is it'll open up this nice little GUI for us to choose which data set we want to link this to. And I'm going to link it to Astra Products 5, as we just created. And we're going to link this via the column of product ID, right? Because notice that we have a product ID into view, and we have a product ID in my, my Astra Products data set. Right? So we're going to link into this. And then the link name is just going to be Astra Products, right? Just for us to know what's going on there. As I click apply, remember how we set up the name of the product as that initial label? So that's what we bring into view. We bring in a new correlated column with the name of the product, right? And it's in green, meaning that there's a correlation in the back end there. So what we've done is we've just joined our new, our first data set. And notice that, once again, the default name is coming in as the label. But what I could do is I can add related fields from that old data set that we just had. Things like the price, right? Things like the name, the categories, description. And I can bring everything into view here, and we can sort of apply and once again use schema on demand to modify the schema of my, once again, logs view is what we started with. Now, one more thing that I'll sort of point out here is that Observe types all of its data. So if I want to take something like, let's say, price, and it's a string, I need to make sure that I modify it or I convert it to an int, right, before I can go ahead and build a visualization on top of it. And this, once again, sort of writes the Opal for us, everything on the back end. So worksheets have a slight different flow to creating visualizations than explorers do, but still, we can click this chart button here, and it'll give us sort of a count of how many products we've added or how many products or logs we've seen. What we want to do is just do a quick sum. Or is it sum of Astra Products price by Astra Products? And hopefully what that'll give us is how much we're getting paid by each product, right? And someone like Kyle would love this because then they have some business insights as to where to focus our efforts on. It seems like optical tube assembly is is super profitable.
I'm a big fan, yeah. Optics of any kind. Yeah.
I noticed I might have used the Astra Products price when I should have used the currency or the value. I don't know. In any case, it seems like we're making a lot of money off of this, and it's the same end goal.
That's right.
Now, just to sort of save this for later use, we can just add this to the dashboard that we created earlier, right? Recommendation service 2 here. Bring that into view. And if I refresh this, we should be able to see that third beautiful bar chart that we just created to keep track of, how much money we're making off of each product. Awesome. Perfect. Bonus question, and I guess our last question here is going back to this worksheet right here. Which product by name? Do we have a question for this one, Kyle, pre-built, or this is just a bonus one for them to figure out?
Yeah, it's bonus. So they don't have to answer via Zoom. They just
Okay.
want them to think about it, just go really feel it out.
A little
Fill out the
challenge.
space. Yeah,
a little challenge. All right. So the total question is, everyone, which product by name has the highest number of add to cart actions in the last 4 hours? So not price, actions. How many of them have been? What's the product that's been added the most? Think of it as your PM giving you some homework to figure out more business insights. Awesome. I think we're done here, right? We've covered, well, let's just recap what we covered. We went through a troubleshooting workflow to figure out what was wrong with our recommendation service within our front end and in our e-commerce application. And then as a little bonus, we found out that there were other problems, within some other services that we were able to remedy there. Then lastly, we went through some Opal exercises. We built some really nice visualizations here and added them to a dashboard. And we hopefully learned a lot along the way of Observe and the powerful platform that we've created here. So just to sort of finish some housekeeping items here, everyone. First of all, thank you. Right? Thank you for joining us through today's workshop. You're going to get a survey, probably from Grant, to give us some feedback on this. So it'd be awesome if we could get some insights there. The trial that we just created is going to be yours for you to use for the next 14 days. So feel free to play around with it, add some data, your own data if you want. Just explore as much as you want. If you're interested in a data shaping session, reach out to schedule some time with Grant. And please feel free to join us for our next webinar with our one and only Keith Buswell, one of our other sales engineers here within Observe. It's going to be a workshop on navigating regulatory compliance with observability, a modern approach, on May 16th. Right?
Love
so
it.
if you enjoyed this one, you'll love that. With that, I'll pass it back to you guys, Kyle and Grant.
Yeah, so just for me, thanks everybody for signing up. We're actually using Observe to watch folks sign up because we've actually instrumented the provisioning code. So it's always exciting to see folks log in. So thank you for taking time today. I know time is precious, right? So really sincerely appreciate folks just going through this, and Lucas, obviously, for doing such a great job. And I will do a shout out as a product manager of a SIM product years ago. Regulatory compliance near and dear to my heart. Probably the nerdiest thing I've ever said, but it's actually a pretty good one. So if you have colleagues on the cybersecurity side of your teams, encourage them to check this out. We actually have some pretty interesting stuff to offer on that front. So, and then Grant, if you want to close this out, my man.
Yeah, thank you so much, Lucas and Kyle. I'll have everyone's Observability Innovator certificates out no later than tomorrow, and hoping to see everybody on our upcoming webinar. Thank you so much for running this, Lucas and Kyle, and I appreciate everybody's time today.
Thank you,
All right,
everyone.
thanks, everybody. Take care. Have a great one.
Take care.